Hi everyone. Sorry for little technical problems. You cannot rely on Mac when it connected to the desktop. So my name is Alex Suevalov, and I work in data art. And today I'm going to talk to you about the code splitting. So hands up, who knows what code splitting is? Not that much. Okay, and who have ever used it in like real application? Even less. Okay, that means that you're my target audience. So first of all, what code splitting is for those who don't know. According to Webpack documentation, it's just something that allows you to split your code into various bundles, and then you can load them on demand. For example, the easiest example is when user navigates on a website, it visits different pages, and while the user is navigating from one page to another, we are gradually downloading the JS code that is responsible for rendering those pages. And I've been doing some research recently on the React apps and asked people what are they using as a bundler. Is it Webpack 1, Webpack 2, Browserify? And I asked either they use code splitting or they don't use code splitting. And what I discovered is that a lot of people are confused by this topic, and even they are using code splitting, they don't fully understand how to do it right, how to avoid common pitfalls, and so on. Let's try to answer this question first. Why do we need to code split? You know that a lot of developers works on really powerful laptops, desktops with a fiber internet connection that downloads everything just right away. It doesn't matter how many megabytes in your bundle. You see the result immediately because it's on your machine, right? Probably even if you're using stage environment and you deploy your application somewhere for QA engineers, for testers, it is located probably in the same network that you are. Probably at the same building or not that far away. But real users are not at the same building, and the server can be not that close, and the downloading time will increase when real user face with your application. And not only that problem, because the traffic can be slow. For example, let's imagine a situation when you're traveling by train and or by metro, and at some point internet connection just stopped working because you're in the tunnel, right? Or it can be expensive when you're in a different country where every 1 megabyte costs you really a lot of money, right? And actually, not only these factors, but mobile web speed matters. According to a lot of researches, on average, faster experience will lead to 70% longer user sessions with more than 2 times more mobile performance revenue. For example, these numbers are according to different companies like Flipkart, Instagram, and so on. Actually, it's more important for different news platforms and websites which are loaded from users by mobile phone. So there are several key points while we are loading the mobile application, and yeah, you can see on this graphic. So it's the first point when navigation begins, when we see the first content, something meaningful, like header or text, probably text with the fonts, default fonts, because like our fancy fonts are not loaded yet. But anyway, user can read something at this point, and then like everything is ready, like visually, but not ready to respond on user actions, for example, to scrolling and so on. And at the end, user can do everything he want or she want to do. And there are some performance goals. For example, the first visit, it should be less than in 5 seconds first. And the second and the following visits should be less than in 2 seconds. Otherwise, users will be pissed off. And it's critical to achieve these points. But is it easy? Actually, it's not that easy. For example, let's take a look on a single page application. We just want to use a Create React app, and out of the box it comes with the React and React DOM, and like little just one page with a loader and some CSS. So let's use it, and as an output we have 2 files. The first file is man.js file, the only one like JavaScript file at the moment, and it's 47 kilobytes gzipped and more than 151 kilobytes non-gzipped, and there are some CSS as well. It's just 2 dependencies, and let's imagine the situation when your manager asks you to introduce a new feature, new fancy feature to your website. For example, like product owner wants user to be able to create posts on your page, like posts with ability to select date where it will be posted, and some emojis, custom stickers, and so on. And they emphasize that all emojis should look the same on the different platforms, on Android, iOS, and so on. So you, as a professional developer, did some research on available libraries and found out that it's better to do this with Draft.js, Moment.js, and Emoji1. These libraries will allow you to build a rich editor without any pain, like in a relatively short amount of time. And everything will work on the different platforms, like from the visual point, it will be the same. Not that complex, right? But what if we build these applications after we introduce these 3 dependencies? Let's take a look. So we just added 3 dependencies, nothing more. We haven't tried any feature yet, and file size just jumped to almost 1 megabyte non-gzipped, right? And it's ridiculous because probably users want to use this feature on every visit. So what's the point to download all this code that is not required for the first meaningful paint, right? Not required to the first visit. Why should user download these precious kilobytes and almost megabytes? Right? So let's take a look in the network tab after introducing these 3 dependencies on the first visit with a hard cache reload. So what we see, the point when this website is fully ready to use is 9 seconds on the first visit. It's quite far away from the point that we want to achieve. It's less than 5 seconds on the first visit. So we need to do something, right? And I think it's time to split the bundle. So basically, let's start from the understanding how it can be achieved in a Webpack or Browserify. There are 2 common approaches to do this. First is require ensure function, and the second is dynamic import. Let's take a look on the first one. There are some downsides and like advantages of this approach. First of all, the downside that is for only for Webpack, and it should be mentioned that this function will be deprecated in Webpack 3 or later, and there is a reason of that. I will tell you later. But also, it relies on promise internally. So if you want to use this on a IE11 or more old, so for all browsers that don't have promise out of the box, you have to polyfill it properly. So the function is just with 4 arguments, and 2 of them are optional. The first is a list of dependencies that will be downloaded, but not invoked, I would say. And the second is callback, when all dependencies will be downloaded. The third is error callback. For example, if you're in a tunnel at some point and the internet just stopped working, so the error callback will be invoked. And the last one, but not least one, is the chunk name. I will show you a little bit later. So, for example, let's imagine that we have to determine date by moment.js, or use some fancy moment.js function at some point. And if it was asynchronous, we just used it like import moment and then moment dot something. But with require ensure, we convert it to be asynchronous. And this particular example, we see that we require ensure empty array. That means that this function not require some third-party code. And then we, inside the second function, we require a dependency. And all dependencies that will be required in the second function, they will be bundled to the separate file, JavaScript file. So I just replaced one function in my imaginable code from being synchronous to being asynchronous with the require ensure. Let's take a look in the output and see. So we see that something changed here, and we have one more file which called 0.blah.chunk.js. This second part is a hash of the content, so it's on every build it's changing. But we see that main.js bundle lose some weights, right? And it's moment.js actually. So the dependency that is not responsible for the first contentful paint is separated, and it will be downloaded once user approach this feature that requires this dependency. And it will be downloaded asynchronously. Let's change it a little bit, and we, in this code, we just added fourth or third optional parameter is a chunk name. It's really useful for you to do it in your code, because with this feature, you will receive the following output. So instead of 0 something chunk name, you have named chunk. And it's really useful for analyzing it later. I will show you some tools how to analyze your bundles. So for example, you have like text editor that will be like downloaded asynchronously. You name this chunk as a text editor. You have some different feature. You name it like my different feature, and so on. And later, you'll have named output chunks to analyze. It's easier to find out where does it come from. Okay. Also, you can pass like dependencies that will be downloaded to the bundle but not invoked. For example, in this particular example, we specify that we want to require load earlier JS into this, and it will be bundled in this chunk. Regarding require ensure, you can read it on the Webpack documentation. It's really it's really good covered article. So and the second and actually better way to use asynchronous loading is dynamic import. What's the difference from typical import that we are all familiar with? That is actually it's a function that returns a promise. And what's good about this? That is the actual official TC 39 proposal. It's a web committee that is responsible for introducing new features into JavaScript, HTML, and the web. And this proposal on stage number 3, that means that it will be probably accepted without any changes. So what does it mean? It means that in a short amount of time, we'll see this feature natively implemented in all browsers, like new browsers like Chrome, Firefox, and so on. So it's better to put money on this guy instead of the previous one, because later you can even to remove Webpack from the pipeline, and it will work in browser out of the box. So it also relies on a promise, so you have to polyfill it. And if you use the Webpack 1, it might be a problem because it works only in Webpack 2 at the moment, but like upgrading from Webpack 1 to Webpack 2 is not that complicated. And also requires like a little Babel plugin to work. I'll show you how to do this. So the same example, just instead of without requiring sure, we see dynamic import, and we specify that we import moment, and when it's ready, we have a promise that return default from this module. And we specify a special comment here to tell Webpack that this chunk will be named like this. It's like a workaround instead of an optional chunk name parameter in the previous function. So how to enable this? You have to add one parameter to Babel ESLint. It's allow import export everywhere to true, and to install one plugin which called syntax dynamic import, and place it into your code. The good news that actually all this stuff is built in Create React App. So if you use it, just don't worry, the guys done work for you. So now we know how to use it, yeah, like from a syntax perspective. But it's also important to understand how we can use it from a functional perspective. And the first and the easiest way to split your application is route-based splitting. So let's imagine online shop where you can buy trousers, right? And when you visit like the main page, you see some grid of a little images with different fancy trousers. And then you just scroll down and scroll up, yeah. And then you found the one you want to buy. You click on this item, and you go to the next page where you see all details about this item. And so you decided to buy it. You click on the checkout page, and you go to checkout page where you see like the final price, where you can remove item, add like continue shopping, and so on. So the most trivial thing is to load the code responsible for rendering different pages asynchronously. So, for example, first of all, users just need one code that is responsible for main page, right? Then, only when user clicks on this link, we need to download the code that is responsible for that link. Actually, it's really easy to do with require, ensure, or dynamic import, and it's really easy to do with React Router or React Router 4 or 3. It doesn't matter. Actually, it is the base place to start to play with it because it's really easy to do, and potentially it's maximum like output from little effort, and like output is really good. For example, you can use like Moment.js or some heavy dependency on the only page, for example, in user settings, and actually users never go there. Like only in 5% visits they go there. So what's the point to download it from the very beginning? It's just ridiculous. And the one downside is the router has to be async aware. But the good news that like the most commonly used library React Router is async aware, so it won't be a problem. And you need to be beware of the code duplication in output. So, for example, several pages uses the same dependency, and you may end up with like this code dependency to be duplicated in several chunks. It can be avoided with the common chunks plugin I will show you later. So, example with React Router 3 and dynamic import. So instead of parameter component equals React component, we can use a parameter which is called get component, and which accept a function which have a callback, and it will be called when promise is resolved. Actually, promise can be like even like API call, but at this point is asynchronous loading of the code, right? So if the promise resolves, we return this component to render. If we have a catch, so that means that this code is not downloaded, we render nothing. As this particular example, we can enhance this a little bit, and we will enhance it a little bit later. The same example, but instead of dynamic import, we use require ensure. Well, not that much change, just the syntax, but the idea is the same. So let's skip it. So the first and the most easy way was router-based splitting. Yeah, but we can do better, because, for example, in React, like route is just a component, right? So what we optimized, like downloading, asynchronous downloading of the code instead of routing, but just delegated to components. For example, the best way to use async component splitting is different kind of mobile windows, pop-ups, something that is probably on a page, right? But it's not visible before users do some manipulation to open it. Yeah, the perfect is like model window. But for example, it can be something that is not in the viewport on a first visit. For example, the page is long, and there are a lot of, like, I don't know, there is a YouTube video at the bottom of the page. But to see this, user needs to scroll it down a little bit. So what's the point to download like a YouTube player code that is really heavy actually on the first visit? It doesn't make any sense. You can like defer it a little bit and load it asynchronously. So so on this image we have on the red image we have like router-based splitting. It's like a tree, and with enhancing this approach a little bit and using async component splitting, we have a tree that is like every branch is split as well. So you download on the one page, you download the code asynchronously while user manipulates with this page. And at some point, user can download everything, but can also leave the page and skip it. So how to convert any component to a sync component? Actually, it's really easy, and we can write like a wrapper component for that. Let's call it a sync component. Yeah, and what is it? It accepts 3 properties. The 1 is required, and 2 are optional. So the required parameter is loader. It's a function that it returns promise. Also, it's render placeholder and placeholder heights. So why do we need a placeholder? It is something that will be rendered while your component that you want to show is not loaded yet. For example, it can be some spinner or like a fake component that looks like YouTube player, but it actually is not YouTube player, it just looks like YouTube player, but it is just CSS without any JavaScript. So users won't see the difference, actually it just will be replaced once the code is loaded. We have a state like component, which by default equals null. And one component did mount on a page, we started to load the code. We call a loader function, and when it's resolved, we set state. So render responds on this set state. So if we have a component, render component. If we don't have component, render placeholder if it's passed. Otherwise, render nothing. So it was a wrapper component, but we can create a high order component from that. It's just a function that accepts loader, which returns a functional component, which wraps pass component into a sync component. So it allows us to reduce a line of code which we need to write to transform every component to asynchronous. So, for example, you have a login page, which you need to download only for not authenticated users, right? You create loader, which is a function that returns import, dynamic import, and this import returns promise, right? And we require login page. Then we can just like transform login to sync login, just make it a sync with the previous code that I showed you earlier. So make it a sync and pass loader. So and you have a synchronously loaded component that will be loaded when you put it in your React code. Example with React Router 4. So instead of placing components just right away, we wrap all router and make it a sync function and pass it to match component. So it means that loader that is specified on the line number 1 will be invoked only when users go to page/foo. And this code will be downloaded only when users goes to page/bar. It's really easy to do. Just you create one component and wrap it to make it a sync, and you're done. Like instead of one bundle, you have 10 bundles, and the user will download this code asynchronously. By the way, this presentation is online, and I'll share a link with you, so you'll be able to click and copy the code and so on. But instead of creating your own async component, you can use some npm stuff, right? And probably the best library that is responsible for asynchronous loading is called React Loadable. Install it and use it. So what we have on this example, we import React Loadable, and we specify like loading component, our custom loading component that will be rendered while code is not loaded. And instead of make it async, our custom function, we use a loadable function, and it accepts two parameters, loader as well, that returns a promise, and specifies a component that will be rendered while it's loading. So what's the difference, you might ask me, right? But there is a difference. There are a lot of edge cases covered in this library. For example, error handling. For example, how we can deal if the code is not loaded, right? In our custom loadable component, we have optional parameter error, which is true if a chunk is not loaded, and we can render like some red screen or I don't know 404 page or something like this if it happened. Also, it's resolves avoiding flash of loading component problem. What is it? Some studies say that it's better to show nothing in like if something loads really quickly, like less than 200 milliseconds. It's better not to show a spinner, because according to studies, that people just don't see the difference, and actually spinner gives more annoy for user. So it's better to render nothing, like even if it's loaded in less than 200 milliseconds. And this case is covered in this library as well. We have optional parameter like pass delay, and we can like render error if the error occurred. We can render spinner if we have pass delay, so if the component is loading more than 200 milliseconds. Otherwise, if it's loading less than 200 milliseconds, render nothing. It's better for user like experience. But we can go even deeper, and we can predict what user gonna do with our application, and to be quicker. Yeah. For example, let's jump back and remember the trousers online shop example that I introduced to you. So, for example, we on the second page and we want to go to checkout page, right? And when we are mouse over checkout button, probably you can predict that user will click on it, right? So it's like 80% that he or she will click on it. So yeah, we can specify mouse over handler that will call loadable component dot preload, and it will start to download the code even before user go somewhere. Yeah, and actually we can go even further. For example, there is a really cool utility component which called perimeter. It means that it have like a callback when user approaches something like on a specified box from a something, right? For example, in this particular example, we say if user approaches your component by 60 pixels, call the handler. And we can start downloading something when user approach like footer, for example, right? Or we can predict when and prefetch something when users like goes on the menu. And for example, when users just approach something, we can already download it, and like the click will be instant. It's really cool. So we covered 2 cases, and it's time for the last but not least. It's a vendor splitting. What is it? For example, you added like 7 third-party dependencies to your application, and after that you just stopped. And instead of adding third-party dependencies, you write your code. and you release new features like every day, right? And when you do release, like every JavaScript file is changed a little bit, and the hash of the JavaScript file will be different. So what does it mean for end users? It means that they have to download it once again, because it's a new code. But what's the point to download all dependencies that haven't changed once again? For example, in our example, it can be React DOM. We haven't upgraded this third-party dependencies. We haven't changed it. We did nothing, but like poor end users have to download it again. It's unfair. So we can use common chunks plugin in Webpack and extract all third-party dependencies to separate file and enable like severe caching on a for example, on Nginx with little big expiration number to avoid like second downloading of this code, and the browsers of the end users will cache it as well. So on a subsequent visits, if some functionality changed, but the dependencies are not changed, user will download only change code of your function, like functional stuff, not third-party stuff. So we can do this by adding one little plugin into Webpack configuration. For example, in this particular example, we separate everything that is in Node modules to vendor chunk plugin, right? But sometimes it's not cool, because as we already explored, some third-party dependencies are used only in really like small cases. So, for example, we can modify it a little bit and say that we want to extract all dependencies that are used twice to separate bundle. Or you can increase number to make sure that only like commonly used dependencies are extracted to separate file. I would recommend to do like 5 or 6 to play with it and to see the output. Also, we can extract specific dependencies to separate file. In this particular example, we extracted React DND and stuff, and all related stuff. So by doing this, we can avoid code duplication in chunks by extracting dependencies to vendor chunk plugin. So you can use route-based splitting without any problems. But how to analyze your bundles, right? We talked about how to do this, but how to detect the point when you need to stop, breathe, think a little bit, and to do some actions. How to detect that you're in a bad situation and there is a bottleneck in your bundle. So actually, there are a lot of third-party tools to analyze it. And the simplest is to use a like small performance setup in a Webpack prod.js. You can specify maximum file size, and if some of the chunks are over it, it shows you a warning, or instead of warning, you can do error. So like it's, for example, it's convenient for continuous integration setup, and you can like stop building the application if someone accidentally added dependency with 10 megabytes of the JavaScript code, and it won't be deployed to end users. You can just stop building the application when it appears. Or you can use a Webpack output. It produces a JSON with like verbose information about build steps and stuff, and you can download it to a lot of online visualization tools. So a lot of different tools, but actually I would recommend to use one. It's called Source Map Explorer. I use this on daily basis, so just install it globally and then use it in a terminal just specifying relative path to the file that you want to explore. And it opens a page in your browser, and it visualizes all dependencies tree, and you can click on every cell and go further to detect like dependencies of dependencies and so on. So you can do this with, for example, with any file, and playing with it like in 1 minute, you can detect that, well, this code is not used anymore, or this code is used only in 5%. Probably we need to think to move it away, and so on. Few more advices: profile on real devices. If you don't have real devices, always use feature in Chrome where you can limit bandwidth connection to 2G, 3G, 4G, or to increase like response time, and avoid request waterfalls. What does it mean? It means that, for example, some dependency need to be loaded asynchronously, and to load this, you need to load something asynchronously again. So instead of loading it once in like 20 milliseconds, you load something 3 times by 10 milliseconds. And as output, you have 30 milliseconds instead of 20. So just keep network tab opened, and that's it. Well, I used these links to prepare a presentation, so every link is clickable. Thanks.
Thank you. Hello, my name is Viacheslav Shevchenko. I am front-end developer from Data Art, and today I will be talking about popular approaches in functional JS. I suppose that you know something about functional JS, so my lecture will be not about theoretical stuff. It will be more about practical use cases. And this is my plan for today. We will be talking about high-order functions and why do we need them. Also, I will show you native realization of partial application, composition, and currying. I will show you third-party libraries which implement such approaches, and there will be a lot of practical examples, and also performance won't be missed. I will try to share some common traps which we had on real project and performance issues. What is high-order functions? In simple description, it's just functions for making functions. More advanced descriptions is functions that operate on other functions, either by taking them an argument or returning them, are called high-order functions. It sounds pretty simple and useful, but please don't underestimate their power. To understand them, we need to revisit some built-in language features of JavaScript that makes high-order functions possible. I guess you're able to understand what's going on here. So let's speak about closures. For example, if you define variable inside a function, it can be seen outside of it. But if you define function inside another function, inner function will have an access to variable from other function. In my situation, I defined hope function which accepts a variable. When I call hope with 1, inner function will be returned, and when I provide second argument 2, inner function will be called, and inside the inner function you have an access to a variable 2. Nothing complicated, I guess. The same situation here, but ECMAScript for ECMAScript 6. I guess syntax much more cleaner, and I will be use it further. Pretty similar example like in previous one, but here we have a function like an argument, and when you call whole function, you have to pass that function like an argument. And inside the num will be equal in my situation to 5. And when it will be called, you will see 10, because inside the inner function I have an access to my function from parent 1. This is the main feature around which all functional approach will build. Sometimes it can be handy to create function with prefilled list of arguments. This is where partial application came to the scene. For example, in JavaScript, we can use .bind method for each function. I have my function which accepts an unlimited amount of arguments and returns all that arguments like an array. I decided to wrap my functions to another one and create prefilled function with 1 to 3 arguments. And when I call that function with additional 2 arguments, we will see 1 to 3 for 5. It's because 1 to 3 were prefilled, and for 5 we pass here after it. The main trouble here that .bind function expects first argument like a context of execution. And even if you don't want to use it, you have to put here something, for example, null. Let's try to get rid of it. This is a simple realization of partial application. The main idea is partially apply any number of variables to function which expect any number of arguments. Here, I converted arguments variable to an array via slice, and I suppose that first argument in that array will be a function which I want to prefill. And inside the inner function, I got all another arguments and merge them with parent one. And after that, I call that my function which I want to prefill with all amount of arguments via args.concat remaining args. The same situation here. We don't need so much space here for ECMAScript 6. First argument, as you can see, just a function and another remaining args. And after that, I call that function with all amount of arguments. I have some function which accepts two arguments, a and b, and this function returns some of them. If I wrap my sum function via partial application, I decided to prefill first argument a with value 1. And after that, I call that I got with second argument 2. And finally, you will see 3. Not reconciled, I guess. Another situation with objects. Let's suppose that I have my object where custom name, prop, and getMessage method defined. And if I call that getMessage method like method of that object, you will see username 1 has been logged successfully. It's because context of execution, this will refer us to my object, and it will be able to find custom name there. But if we call getMessage via partial, it won't be method anymore. It's just a simple function with profiled logged argument. And in this situation, you will see undefined has been logged successfully. It's because in this case, this context of execution will refer us to window if we are talking about browsers, or undefined. And custom names won't be defined there, and you will see undefined has been logged successfully. If you want to specify context of execution, you can do it with via .bind, and everything will be working in regular way. Functional programming is about taking small, simple functions and piecing them together to do more complex things. Partial application, as we saw above, it's a tool which helps us to make this process easier. And composition, it's another tool for combining simple functions together. Let's see this scheme. For example, I have 3 functions, function 0, first, and 2. And if I create a composition of them, my compose function return another one. And when I call that function, composed function with value, some value, firstly, function 0 will be invoked. And my function 0 does some operations, some executions with that value and returns some result. And that result will go to the next function in sequence, to function 1. Function 1 does some of operation and return result to next function, and so on and so on. And finally, you will get a final result here. The simplest form of composition is these two functions, function 1 and function 2. And compose creates third function, and when you call compose function with value, you will get a result of execution of function 1 with result of execution function 2 with value. I guess it's pretty confusing mess, and I hope that it will be more understandable for you after some examples. And this example how to create composition with unlimited amount of function in sequence. Let's suppose that my compose functions awaits unlimited amount of arguments. And here I got last number in my, I got last function here and assigned number of that last function to start variable. After that, inside inner function, I expect some arguments. And I decided to call my last function with that arguments and save result of execution to result variable. What I need here is just go through the sequence of my functions and every time call next function with results of previous one, like here. And after that, I return final result. That's how can I use it. I created composition of two functions, parse float and mass round. When I call number v72.5 string parameter, firstly parse float will be executed and 70.5 will be converted to float number. After that, result go to the parse round, and that result will be rounded successfully, and you will see 73. Limitation of compose is that it expects all the functions passed in to take just one parameter. Current another approach, and I will say that current is a series of applications to the function. Let's see at the example how we can use it, and after that I will show you implementation. It will be more understandable, I guess. For example, let's suppose that we have an application where we several forms specified. For example, form for registration and form for authorization. And I have getValue function which returns value from form by field name. And I decided to carry that function with form variable, with first form variable. What does it mean? That means that next time when you call getValue with first form, you don't have to float the form variable anymore. It's already will be there. You just have to float the field name variable, this one. And one of the cool feature of this that you can reuse that getValue with first form in different parts of your application, even in those where form variable is not available. And I have second form for authorization, let's say. And I decided to carry that getValue function too, but with form from second variable. That means that every time when you call it, you will get a result from second form, not from the first one. This is a really powerful feature. And how to implement it? We have a carry function which expects first argument as a function and remaining args. My carry functions creates another one, and inside the another one, I merged all arguments which I have in parent one with current argument, only one. And after that, I have a little bit magic. Function.length, a parameter for function, returns to you all amount of arguments that this function expect. And I make side check. If all args.length, that means that if all amount of arguments which we have for now more or equal than my function expects, I will call that functions with all amount of arguments. If no, I need to carry one more time my function and return carried version. Here I have some function with 4 arguments, and it awaits that it will go for arguments. And if I carry that function with only one argument, you will see if you do console log, you will see current version of this function, current args, and so on, like here. The same situation for 3 arguments. We have here just 3 arguments, and we expect that we need to 4. And when you call that argument first time, that function first time, you will see 7, because this check will be executed, and function with all arguments, my sum function will be called, and you will see 7 finally. This is really cool feature because you can initialize your function one time, for example, for login, and after that, a current version of your function flow through all your application, and for different parts of your application, use these different values in your arguments, and first value or second value will be predefined there. All this functional hell came to us from Haskell language, and please be aware if you start to use it, maybe Haskell drag on you. And you don't have to write native realization of this function manually in every project. You can use popular libraries like Ramda, Lodash, or something else. I would say that Ramda has more functional-oriented structure, and Lodash has a lot of functions, has a lot of methods for different cases in your lives. I will be using Ramda further, but of course you can use whatever you want. And I promised you to show some practical use cases, and for Karen I already showed something, but for composition and partial application, examples were not very useful, I guess. I will try to fix it. I hope that some of you know about React. React, really cool library which allow us to write components in functional way. That means that we have stateless components, and our components is just one simple function. This is a not class component, this is just simple function. Here I have my button component which expects props where change mode and mode ID defined. And obviously my button render button with specific ID and on-click event. With partial application, I am able to define on-click in such way. That means that when you click that button, change mode function will be called with predefined mode auto and on-click event. If I want, that's how I render my button with change mode and mode ID. As you can see, my change mode expects two arguments, mode and event. But if I want to do it without partial application, I have to write like here, because I need to define function which expects only event, and after that I need to call change mode function manually and flow the event and mode auto. But thanks to partial application, I can do it in one line. Another example, more complicated, I guess. It's a pretty common example which I had. And for example, I have a module, external module, scoped module, and inside that module, I decided to use local storage as a storage for my data for my application. You can use whatever you want. Here I created storage variable where all my stores will be, and I have a get storage function which creates storage and returns that storage by type name. By default, I use local storage, as you can see, and you can use, for example, something else. And here I just put it that if I have local storage, I want to assign that local storage to my storage variable and return it. And I have a parsing function. This is function which expects two arguments. First, this is a getValue function, and second, this is an object where field name defined. And this function returns another object where key will be a value from field name and value will be a result of execution getValue with field name. And I have third function which called with default storage. That function extends my props, that props, with additional key and value. Key by default will be storage, and value it's my local storage library for my data. Let's suppose that I got from server side some structure with my data. I have an array with objects, and each object must, if object must has field name key and some additional keys. It could be validators or something else. It doesn't matter. And I have another module, scoped, which has an access to my data. And I have a getValue function like in current example. This function just return value from by field name. And I decided to create a composition of three functions. What does it mean? When I call that composition with data variable, firstly, map function will be called. I believe you know how map function works, and it applies some function to each node in my array. In my situation, that function will be applied for each node in this array. And for each node in this array, a parsing function with predefined getValue variable will be executed. Without partial application, we are not able to use getValue like a first argument here. After that, I decided to create additional node in my JSON structure, and I called this node result and put it there all my result. My third function with default storage extends all my result with a storage node. Here I have storage, and it will be added to my result, and so on. You can create unlimited amount of function in that sequence. For example, further I can skip all my result data there and save the data only in local forage here. But for now, inside the parse data, you will see such result after execution. Storage with local forage or another library which you decided to use, and result with simple structure where you can see only username and email. There are no field names keys, there are no validators keys, and so on. It's pretty simple and useful. And I hope that it was understandable. So, welcome. Why is the dark side? I will explain you. Do we have such issues with functional JS approach? Yep, we have. Let's speak about React. This library, as I told you before, is pretty cool, and main feature is this possibility to create stateless component. And it's pretty cool because you can use with your stateless component all that approach in functional programming. You can create composition of them. You can use partial application for them. But the largest epic fail of React developers that functional components slower than the class components. What's wrong with the functional components? Dan Abramov is one of the authors of the Redux CLA project generator Create React App, React Hot Loader, React DND. Also, he takes participation in developing React.js. And this is a quote from his tweet. He mentioned that there is no optimized support for stateless component yet because they wrapped in a class internally. It's same code path. That means even if you write stateless component, it will be wrapped to a class behind the scene. So you won't have speed increasing. Your component will have some lifecycle hooks like component did update, component will mount, and so on, like a class component. I prepared for you several tests. I decided to use React Perf library. This library allows us to measure time for rendering React.js component. And first component, this is just pure component which renders I property with one div node. Second, it's regular class component, and it does the same. Third one, it's pure class component, and that means that that component use should component update hook. Default behavior of React components that is to render your component every time when state changes. But if should component update hook returns you false, component did update, component will update, and render hooks won't be invoked. And if your props won't change, please use should component update hook or use pure class component. And the last one is a pure stateless component, but with default props functions from Recompose library. Recompose is a great library for React, which allows you to write your code, your components in functional way. You can split different parts of your component in your application, and after that get and gather it together. And for example, you can use default props hook, which predefined some default variables, default props like a name, or you can use state in functional way without any side effects. It's really cool library, and we were using it, and this is a test to show speed of this library. And that's what I got. First is pure component without anything, and to render 10,000 times that component, it took me almost 106 milliseconds. How much time will be for a class component? Anybody? Almost 93. Pure class component, 86. And final one, yep, we have a winner. 188 milliseconds for rendering with default props, and this is just default props. If you want to use all another features, speed of executing won't be very high. You know, it's really sad, and mostly this is a problem of React rendering core. But I have a good news for you, because React developers promised us that in the next release of the Virtual DOM library, they will fix such problem. Another issue we had with memoiz from Lambda. Memoiz is a function which catch a result of function execution, and next time when you call that function with same argument, you will get a result from catch. Your function won't be executed one more time. And we were using it too. Here you can see execution of factorial of number. And I created catch function for that factorial. And this is a simple test in browser console. I measure how much time do I need for execution 10,000 times factorial function of 5, and I did the same test for factorial catch of 5. Here you can see a result. For factorial 5, it took me 15 and 8 milliseconds. And for catch function, 22 and 6. What the hell? Because catch function, I don't know, should be faster, but it won't. Please don't use random memoiz. Thank you. If you have any questions, go ahead.
Wouldn't memoiz be faster if you'd called it a few more times with same arguments?
Yeah, because, for example, first time when you call it, it should store your result of execution in catch. And after that, if you call it one more time with the same argument, it should return you that result. But as you can see, speed wasn't increased.
Okay.
So there are several another libraries which can do it. I don't remember name of those for now, but random memoiz shouldn't be used.
Yeah, regarding the memoiz function, I would say that it's worth to use it if the calculation time of a function is not trivial. Let's say like 100 milliseconds for each call. And if you use memoization in this case, you will see better performance as output. Because right now it's just like the function call is less than over performance issues if you have like separate closures. So if each function call is more than 100 milliseconds, it's worth to use memoiz, otherwise it's not.
Okay, thank you.